then as you first through here, the first one is that we do the operations for the behind one. If you want to do this part first, it also can. Just the difference calculations in the previous one. For me, I prefer to do the factorization. I just prefer to the textbook. So from here, this one, we just write it back. And then again, it's the same thing. Just do the matrix multiplications as you first to here. This one is 4 times 4 matrix. This one is the vector that is 4 times 1. So as you first to here, you know that the dimension which is same at here. So in the end, you will get either vector which is in form of 4 times 1 as here. So as you first to here, just the same thing. You do the matrix multiplication. So you will get E as x1 plus 2x2. The other one is 0, so no need to write E, and then move E to the second one, 2x1 plus 9x2 plus x3. The last one is 0, so I didn't write E. Move E again to the third row here, so x2 plus 9x3 plus 4x4. And then for this one, so just as 4x3 plus 3x4. Okay, and then you first show here is 1 times 4, 4 times 1, so the dimension is same. In the end, you will get it 1 times 1, so this one is not in matrix form, just in row, just write it down. So which is equals to, so just the same thing, multiply with all this part. So x1 multiply with x1 plus 2x2 plus x2 over 2x1 plus 9x2 plus x3, and then plus x3, x2 plus 9x3 plus 4x4. Okay, so based on here, just try to expand it. So it becomes x1 squared plus 2x1 x2 plus 2x1 x2 plus 9x squared plus x2 x3. Okay, you get in this form, and then just the same thing. For me, I prefer to take out the square term first. So this one is the square term. I may just write it first. So which is equals to x1 squared plus 9x2 squared plus 9x3 squared plus 3x4 squared. And then plus, so against the thing, just get the terms that here. So plus 4x1 x2 x2 x2, so plus 2x2 x3. This one plus 8x3 x4. Again, the same thing. Since from here you know that all this one that is greater than 0, so you have to do the factorization in order to make it in bracket, in square bracket. So you know that that is greater than 0. So now, so again, the same thing. So different in the previous one, you have to do 3 factorizations here. Okay, so So for x1, x2, and then this one is 2, x2, x3, this one is x3, x4. So it refers to here x1 square, x2 square, and this one is x2 square, x3 square, and also x3 square, x4 square. Okay, how I know that since it refers to here there is x1, x2, so for sure you know that there is some variable in front of it in order to get it the summation from here, which is in this form. Against the thing, so for this part there is the multiplication. For this part there is as the summation. So it refers to here that is for x1, x2, so that means that the summations you will get it 2x1. Okay, just have a try first. So 2 plus 2 you will get it as 4. So it's just the same thing, write it down. So x1 multiplied with x1, that is x1 square, x2 multiplied with x2, that is x2 square. So x1 times x2, you will get it as x1, x2. In order to get it as 2 x1, x2, that means that you have to multiply with 2. Same go to here, you want to get it as 2 x1, x2, so we have to add on the variable. So from here, you know that 2x2 times 2x2, which is equals to 4x squared. So this one, that's for this part, and then another one, we just have a try it here. So 2x2, x3 at here, maybe just as x2, x3, the summations of x2, x3. So you will get it as 1 plus 1 equals to 2 as refers to here. And then just the same thing. Okay, so cross multiplication s2, s3, so this one I fulfill the conditions already, no need to modify it, and s refers to here as s3, s4, let's say that 1 as s3, s4. So the summation, this one is going to be 4 plus 4 equals to 8, and then this one x3, x3, x4, x4. Since s refers to here, there is 3x2 squared. So for sure, you may use 2x4 squared only. If you use 4, so this time it become negative. So for sure, negative of any positive element, it should be equals to negative. So it should be less than 0. That is why I just use 2 elements at here. So actually for this part, there is a different answer at here based on the factorizations you are choosing at here. So for this one, let's say that I choose 2 at here, so that means that just divide it into both at here. So this one, it should be square root of 2, square root of 2. Why I know that? Since you know that square root a times square root b equals to square root ab. So from here, square root 4, which is equals to 2. So for this one, just square root of 2. So once you multiply it, you will get it as original 2 at here. And then for the coefficients of s3 at here, just the things that you know that a times square root 2 equals to 4. So a, which is equals to 4 over square root 2. So which is equals to 2 over square root 2. So again, it's the same thing, 2 over square root 2. So 2 over square root 2 times 2 over square root, 2 square root 2 multiplied with 2 square root 2, you will get it as 2 square root 4. So square root 4 equals to 2, 2 times 2 equals to 4. Okay, I made a mistake. Yeah, sorry, I made a mistake. 2, 2, 4, 4 times 2 equals to 8. Okay, so just 13 equals to 4 square root 4 equals to 4, 2, so equals to 8. So this is why in the end you will get yes 8 here. Okay, once you get this one, just repeat the same thing that is refers to here. x1 plus 2x2 square equals to x1 square plus 4x2 square plus 4x1 x2. And then this one, x2 plus x3 square, you will, I should write it in this way. Okay. x1 squared plus 4x2 squared plus 4x1 x2 equals to just the thing, should write it in bracket form here. So x1 plus 2x2 squared, and then this part. So which is equals to 2 square root 2 x3 plus square root 2 x4 squared. Just the same thing, write it in bracket form. So I want to share with you. Okay, so up to you if you want to gather the information first. It's also acceptable. For me, normally I just proceed it, but I think it's better that I show with you. So from here, x1 squared plus this one, summation is this one plus 5x2 squared plus x3 squared, 1 plus 8, so plus 9x. And then this one, missing one term here, so this one plus 2x4 squared plus x3 x4. Okay, so since you use some of the terms, so this part is the terms you are using to do the factorization. So from here, that means that from the main equations here, you borrow 1x1 squared to do the operation. So now x1 squared already, and then this one, you have 9. Oh, sorry, I shouldn't cancel off it. Okay, and then you borrow 5 to do the operation. So that means that the remaining term is 4x2 squared. And then we move it to the next one. You have 9, and 9 you used to do the operations already, so you have nothing. You have 3, and then you borrow 2 to do the operations already, so only remaining 1 here. 4 power squared. Okay, and then for the rest, so the purpose for this factorization, just want to cancel off it, so that is why we borrow with the main equation set here in order to proceed to the factorization set here. So for this part, it becomes plus. So since you do the factorization, all these equation becomes this part already. So x1 plus 2x2 squared plus x2 plus x3 squared, and then plus 2 square root 2 x3 plus square root 2 x4 squared. So as you refer to here again, the same thing, all the square terms with the positive coefficients that is greater than 0. So summations of zeros, that means that all the things which is greater than 0. So again, the same thing, just write it down. The matrix A is the matrix positive definite. So as refers to here, I do the factorization based on I just try to do the factorizations at here. So actually, in case of the condition fulfills, other answer scheme are acceptable at here. So just a difference at here, since at here I choose it, I just only consider 2 at here. If you consider 3 at here, actually you just the difference value at here, different calculation for the rest at here is acceptable, so up to you. So for me, I try to do it in this way. The only things that you have to show is just you have to show all the terms in bracket which is square in order to prove that is greater than 0, just the thing at here. So that's all for the previous exercise, and then another one. I'm not sure that you want to take a photo or not. If you want to take, oh sorry. you want to take a photo, maybe you can take a photo. What's the thing? Okay, is it too small? Maybe you can screenshot and then you may it's too small, is it? So I think it's better that I let you to take the photo one by one. Okay, 1, 2, 3, 4, 5. And then okay. The last one. Okay, and then share with you one of the past year questions. So you just take a photo and try to do it on your own. The answer screen is attached here already. Okay, so this one actually is one of the past year questions. So as refers to here, that is using the for conditions. So this one maybe you can have a try on your own. Near while, maybe you can take the photo. Or is it too small? Okay, so maybe you can take a photo and try to do it on your own, just a simple thing. And then I discuss with you how to do the calculation for the Kolesky method. So the difference with the previous one, for the Kolesky method, have to make sure that the matrix which is positively finite. And remember that the question didn't mention it, which specific one you have to use. You just use the theorem to prove it. In case that the question mentioned already, you just follow it. And then so the difference here with the Thomas method is that for this one, we use the matrix multiplications as you decompose it as the lower triangular matrix and it transpose at here, just the difference thing at here. And then, so if to move it to the next example, as refers to here, actually this matrix I shared with you already how to show that is the symmetry positively finite and refers to this question. It only asks you to solve it, so you don't need to prove it, you just proceed it to the calculation. So it refers to here from this one, the first thing is that you have to decompose it. So just the same thing, write it down. Okay, so in definitions and also using the for condition, I share with you how to prove it using this example already. So the matrix is same at here. So there's the same first thing. So difference with the previous one here is the transpose or is the lower triangular matrix and it transpose at here. So lower triangular matrix, you know that the element which is located on the main diagonal and also the lower diagonal as refers to here. So I write E as F, B, C, D, E, F. Actually, as you refers to here, this one as the tri-diagonal, you may just substitute it. This part is 0, the same go to here, this part is 0 at here. Why I didn't write it at here? Since for the Kolesky method, it's not necessary that the matrix which is in tri-diagonal form. So that is why I just show you with the general way. So in case that these two values which is not equals to 0, you wouldn't do the careless mistake here. So the transpose of it, so you just write down the terms in row, in columns to row here. So A, B, D, 0, C, E, and 0, 0, F. And then other things that for sure you will get is the value of D, which is equals to 0. Since it refers to the original one, this one is the tridiagonal matrix here. So once you get it in this form, so again, just the same thing, try to do the matrix multiplications as refers to here. So as refers to here, this one multiply with this one, that is A squared plus 0. And then move it to the next one. So AB plus 0 plus 0. Then move it to the next one. So that is AD. And then for the rest is 0. So you just write E as AD here. And then just the same thing, we move it to the next one. Okay, so A times B as AB, C times 0 is 0. 0 times 0 here is 0. So it refers to the matrix multiplications of the lower triangular and its transpose at here. Actually, for this part, you will get the things which is exactly same as the this corner. This corner will be exactly same as this corner. Okay, and then we move it to the next one. So it refers to here, that is B squared plus C squared. And then the last one. So BD plus CE. This one, just the same thing here. So A times B is AD. We'll move it to the next one. BD plus CE, and then the last one. So we'll get D squared plus E squared plus F squared. Okay, another thing is that please try not to remember it, just try to think it logically. If not, if let's say there is 4 dimensions, you're unable to write it down already. So just the things that here. So once you get it in this form, again the same thing, we do the comparison as refers to the left hand side and the right hand side. So that is why just now I mentioned that this part that is set. So it refers to here A squared equals to 3, so you know that A equals to square root 3. So up to you, you want to use this part to do the comparison, so you want to use this part to do the comparison, since as you know that here, this blue corner, the value which is same. So that is why for me, I just choose the yellow color one. You want to use the upper triangular, is also okay. For sure, you will get the same value. So AB equals to 1B, which is equals to 1 over square root 3. And then other things that, or you can write E as square root 3 over 3. How I know it, same for this one, actually just multiply with square root 3. So it becomes square root 3 times square root 3 becomes square root 9. So square root 9 will get E as 3 here. So during exam, if you use the calculator, I think it's not mistaken, you will get this one. No need to show me both. For the both one and here, we just show me that one of the answer is acceptable already, since the answer is same here. Okay, so this part, nothing I can share with you, just the same thing there. Do the calculations and then get the value. So from here, A that is not equals to 0, so D equals to 0. Okay, as refers to here, you know that A which is not equals to 0, so D equals to 0. And then just the same thing, substitute with the value at here, you will get this value. And then substitute with D equals to 0, E equals to this one, F equals to square root 21 over X. As refers to here, 3 1 zeros, 1 3 negative 1. Okay, just substitute it back here. So normally I just write it down for the only one, and then another one I just write the columns in row. But if you want to write it down based on the unknown's value is also okay. So maybe you can have a try, and then you may check it to left hand side and the right hand side. Once transpose is it same? So if not same, maybe you substitute the wrong way here. But for me, normally I just substitute for the first one, and then for the another one I just transpose it. Okay, so that is why it refers to this question. This one is the tri-diagonal. That is why in the end you will get D which is equals to 0. Once you get it in this form, this one is the lower triangular, this one is the transpose of the lower triangular. So matrix multiplications of the lower triangulars and the temporal variable equals to 1. So for this part, just the same thing. So B from the right hand side. So again, it's the same thing. You may write it down in equations and then just proceed to do the forward substitutions. And it's the same thing, write it down from the previous equations and then just apply the forward substitution. So you will get it from the first one. Ya, terkejut lah. Ya, kenapa?
Sorry, yang Y4 tu tak perlu ke memang tak ada?
Apa? Mana satu?
Yang Y4 atas.
Y4. Ya, you tadi tu. Dia 3 variable je tak ada Y4. Kalau for dimension matrix baru ada. Okay ah. Sebab kat sini memang 3 dimension. So it refers to here, this one is the 3 dimension one. So for the temporal variable, actually just the same thing. That is y1, y2, y3. So 3 dimensions, there is only 3 variable. 4 dimensions, there is 4 variable. So you have to include until y4 here. Actually just now I just did the common mistake here. Okay, so this one is only 3 variable only. And then as refers to here, y1 equals to 1 over square root 3. So just the same thing. If you want to, if you use the calculator will show you this one, just the same thing, just the numerator and the denominator multiply with square root 3. And then once you get the value, actually this one nothing I can discuss with you since just the same thing. So substitute the y1 at here, you will get the value for the y2. And then from the third one, over square 480. Okay, remember that this one just as the temporal variable, so once you get it, you have to proceed to get the unknowns for this question. So one transpose of the lower triangular and y equals to y here. So just the thing that equals to here. So this part just write it down from the previous one. Then this one is x1, x2, x3. So for the transpose, just the thing, write it down here. Against the thing, once you write it down, this one x1, x2, x3. Okay, if you don't want to write down it in matrix form, you just want to just write it in equation form straightly. If you are confident with it, you don't want to write down the matrix, it doesn't matter. But for me, I think it's better to write down the matrix. So it's easier for you to write down the answer in sequence as opposed to here. And then the last one. So just the same thing. From here, we apply the backward substitution. Either write this one also doesn't matter. I just want to show you that I get it from the last equations only. So from the last one, after rearrange it, you will get it as 3 equals to 37 over 21. So maybe here I didn't discuss with you detailedly, since just the same thing, the difference that here, just you decompose it into lower triangular and its transpose at here, and make sure that the matrix should fulfill the condition for the symmetric positive difference. So once you get it, the x3 value, substitute it to the second equation, you will get it, which is equals to this value. And then just the same thing, you substitute it, you will get it as negative 2 over 21. And then as you press through here, so x equals to negative 2 over 21, x2 equals to 9 over 7, x3 equals to 37 over 21. So get this one. Against the same thing, remember, which is in order, there is x1, x2, x3. So backward substitution, that means that you have to write down the answer from the last one to the first one. Against the same thing, you may use the calculator to check it. Maybe you just want to use one of the equation, or you want to use the inverse method, or you want to use the matrix multiplications for the left hand side, which is equal to the right hand side, as opposed to here. So just up to you. So that's all for the Koleski method. Another one more example.
Screenshot je boleh?
Boleh. Nah, screenshot part mana?
Dari forward substitution tu.
Forward substitution. Okay, sekejap. Forward substitution. Ni ke atas lagi ni.
Dari situ. Tak. Forward
Forward je.
substitution tu. Forward dan ke bawah.
Okay, boleh. One, two, three. Okay. And then 1, 2, 3. Boleh tak? Sempat. Okay, plus.
Alright, I see.
Okay. And then move it to the next one. Sorry tak, I memang selalu terkejut sebab I yang cakap je kan. Lepas tu tiba-tiba ada suara tu, I ingat apa, mesti you nampak I jam. I selalu biasa tapi I yang jam tu, you all jangan terkejut. Okay. So as refers to here, wait, next one. So as refers to here, this one is this example. So I think the procedure is almost same. I just show you that some of the important procedure here. So for the rest, maybe you can have a try on your own. Actually, as refers to this question, it asks you to show the matrix A and also have to solve it. It didn't specify the method you have to specify the method you have to use at here. So for me, I prefer to use the theorems to prove it, since the theorem is the simplest. I think it's the simplest one. You just show each of the submatrix that is greater than 0 and then you just solve it. Okay, as refers to this correction, it is two things. The first thing to show it, the second one is to solve by using Cholesky method. So against the thing, so I share with you how to prove it using the theorem and also the value for the lower triangular matrix and also its transpose at here. For the rest, maybe you can try to do it on your own, since I think that just repeat the same thing. And I hope that today I am able to finish this chapter. And also I want to share with you, so for the next week, maybe I just pass the video recording for you all, so that we all can celebrate the festival. And then, if not mistaken, what is the date? Maybe 30. I'm not around. I'm not sure yet. So inform you all later on. So that's all. Okay, so I just prove it using the theorem. So from here, the matrix forms, you know that there is 5, 2, 1, 5, 2, 0, 2, 5. Okay, remember that in case that which is not in arrangement, so try to rearrange it. Maybe sometimes that here this one is x2, this one is x3, this one is x2. Okay, so please make sure that all the elements which is correct at here. And then as you go through here, this matrix form, so we apply the theorem. Just the first thing, we prove the submatrix at here. So the determinants of A1 equals to 5. So that is greater than 0. And then the second one, A2, the determinants of 5, 2, 1, 5. So this one, cross multiplication. So 25 minus, sorry, I made a mistake here. This one, it should be 2. It should first to here. Okay, minus 4, so equals to 21. That is greater than 0 also. And then the last one, just refers to here for the sign. Plus, minus, plus, minus, plus, minus, plus, minus, plus. So for me, I prefer to use the first one. So determinants of the whole matrix, that is equals to positive 5. And then again, the same thing, maybe you just cover it. So you get it as 5, 2, 2, 5. Plus 2, oh sorry, not plus. As refers to here, there is minus times positive, negative, positive, es negative. 2205. And then plus zeros. This one is 2502 as refers to here. Okay, Jay, this one no need to write it. I just want to write it down to show you that what is the thing you are going to get if you proceed to this calculation. So for this one, just the same thing that refers to here. Wait. Okay, so if this one multiply with this one, so 2 multiply with negative, so it becomes negative 2 right here. And then this one positive times positive, so it becomes positive, just the thing I should press to here. And then so this part you may have a try on here, just the same thing. This one ABCD, which is equals to AD minus BC. Okay, you're gonna ask me why in our syllabus we didn't discuss the derivation. So just apply the formula. So for all this one, you know that they is greater than 0. So just the things that therefore matrix A is symmetry positive definite. Once you get it, and then just the things that you have to decompose it. So how to decompose it? So I think this one I don't need to discuss with you already, just same as the previous one. Maybe you can have a try on it. So I should write it here for the lower triangular matrix. Okay, please have a try on your own and then compare your answer with my answer. So the transpose just the same thing. So difference here, right here. Sorry. Okay, so once you get this one, and then you proceed the calculations in order to get it, the value for the temporal variable, you will get it as 2 over square root 5 or 2 over 5. Okay, just the same thing. Maybe you can simplify it so it can be these two different answer at here. And then over 35. This one at 52 over 7 square root 21 over 85. And then the value of x at here, if not mistaken, maybe at here there is complex calculation, so the calculator will keep it in decimal places, so you just write it down. Let me a while, let me to check is it the answer I write here is correct or not. Okay, that. So in a while, where is the thing? Okay, maybe you can take a photo for this part. 1, 2, 3. Yeah. Then here also. Okay, so for me, normally the calculations in equation, I prefer to keep in fraction form, since in the last calculation, if not mistaken, that there is a lot of calculation for the square root, so that is why the calculator help you to convert it to the decimal places already. So you just write it down. If you want to write it in decimal places, it's acceptable. So the important thing here is that when you proceed the calculation, that please make sure that it's consistent. So from the starting, you use it for decimal places, so just refers to it. So in case that the question asks you to keep it in 3 decimal places, you just follow it. So you are unable to keep it in fraction form. Just the things that here. If the question didn't mention you want to keep it in fraction form or you want to keep it in decimal places, just up to you. And then the last part. Okay, so just a simple tree, have a try on your own. So we just proceed to the last method for this chapter. There is the Gauss-Seidel iterations method. Okay, so first to page 60. Understand, so against the thing I discussed with you how to is the thing. Is it not this one? Okay, with me a while. Okay, so it refers to the silver version, so there is page 60. It refers to the letter versions. I'm not sure there, so maybe we just write it out for the Gauss-Seidel iterations method. Just based on the table of content, you will write it out. So as refers to here, this one is n equations with n unknowns. So in general, once you know that the equation which is n times n equations as refers to here. So just the things that you know that as refers to this part, there is the row. So this one is the first row, second row, third row, and blah 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 until the last row. And then this one, 1, 2, 3, blah 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 until the nth row here. Just the same thing. So for the subscript, the first one denote for the row, the second one denote for the column. So just a thing I can share with you. Okay, so again, the things that for here right hand side there is Bn. So if let's say that there is 3 times 3 matrix, so you know that we only consider this part, and then the right hand side there is only this term. Okay, so here just in general form. So what is the Gauss-Seidel iteration? For the Gauss-Seidel iterations, the important thing here is that the matrix must be diagonally dominant. So which is different with the previous one. Previous one, if let's say that the question asks you to solve it using the Kolesky method, for sure the condition is fulfilled here. So for the diagonal dominance here, maybe it asks you to solve it using the Gauss-Seidel iterations, but the first thing that you have to check it whether which is in diagonally dominant form or not. If not, rearrange before you get the calculator formula. So how to get the calculator formula later I will share with you. So just remember that before you proceed the calculation, the first thing is that make sure that it's in diagonally dominant, so you can rearrange the equations in order to make it as diagonally dominant here. So what is the thing? If necessary, so for the step 1, we arrange the maximum equations to achieve the convergence criteria here. So difference with the previous one here, the stopping criteria is the previous value minus the latest value minus with the previous value. Here there is less than the epsilon number. Epsilon number for sure you know it. So k plus 1 we did not e as the latest value. As k we did not e as the previous value. So later I will share with you how to get the things here. And then, okay, so for the first one, that once you rearrange it in diagonally dominant form already, so no worry, later I will discuss with you why is the diagonally dominant. The first thing is that let me to show you how the calculation is going on here. So for the first one, that once you make sure that A11 is the largest value, that means that there is a diagonally dominance already, so you just move the rest of the part, so this part to the right hand side. So just the thing, so it becomes B1 minus this part and then over A11. So that means that you only keep A1 on the left hand side. So we move it to the next one here. So just the same thing. So we only keep X2 on the left hand side. So for this one, since this one we do know the latest value, so that is why here or subscript here is K. For the second one, so you just move this one and the rest of the terms to the right hand side and then over A22 in order to keep H2 K plus 1 on the left hand side. So from here, since you know that the latest value for x1 already, so for the x1 you substitute with the latest value at here. For the rest, since we do know the latest value, we just use the previous value, that is y at here as sk here. And then just the same thing, we just proceed to the next one, this one. So just the same thing at here, the previous two we know the latest value, so there is y at here, there is sk plus 1, sk plus 1. So no worry, later I will share with you how to use the calculator in order to store the latest value in your calculator. And then for the rest at here, since for the rest we do know the latest value, we just use the previous value, and then just the same thing, the coefficients over at here. And then for the xn, so just the same thing, move all previous value and all this part to the right hand side, as you notice at here, since you know the value of x1, x2, x3 and all the value already, so that is why you just write it as sk plus 1 over a and n, just the simple things at here. I think I do in this way already. Is it you need to take a photo? Yeah, good. If you want to take a photo, maybe give me a while. What is the thing? Okay, up to you. Maybe you want to take this one, and then you may read out the thing I jot down at here. To do a digger. Okay, so if you want the original one, maybe you can take a photo for this one. And then if you first to the textbook, you write it as A33. Okay, this one is wrong actually, which is A3N at here. So that's all. So remember that for the convergence criteria, there is just the difference in between the latest value and the previous value, the maximum at here, there is less than epsilon. That means that the stopping criteria is achieved at here. And then, so this one changes as the things in general form. So for this one, that means that as refers to here, you know that for the previous value, or no. Okay, once you get the latest value, you may apply it in case that you don't have the latest value. So you just use the previous value, just how to write the formula in general way only. So it won't become out during exam, just something I want to share with you. So that means that in case this one as x1. So x1 for sure this part is nothing at here, since j equals to 1 to I equals to 1, 1 minus y equals to 0. Okay, y to 0, this one, it should be cancelled off, should be equals to 0 only. So that is why for the x3, that means that you have to use the latest value of x1 and x2 at here. Just a thing, just now I share with you already. So the difference at here is that based on the basic mathematics principle, you know that the summations of 1 to 0, for sure you get yes 0. Any value which is in case that there is 1 to 1, okay, there is at least one terms here. If let's say that there is 1 to 0, which is not in order of sequence, you will get yes 0. Okay, so that's all for this one. And then so this part, is it better I discuss with you? Okay, wait me a while. Nice the thing. So here I just discussed with you with the things that is 3 times 3 dimensions as refers to here. Oh, what is the thing? So as refers to here, let's say that there is 3 times 3 dimensions equations as refers to here. So equals to B1, B2, B3. Okay, so once we arrange, yeah. Okay, once you arrange in diagonally dominance already, just the thing from the first one, you know that it should be the latest value. So equals to B1 minus A12 x2 A13 x3. So this one we do know the value. the latest value, we just use the previous value over A11. And then we move it to the second one. Then this one is the third one. So from the second one, that is equals to V2 minus A21 x1 minus A23 x3 over A22. As refers to here, since you know the latest value of x1 already, so that is why at here we use the latest value. And then we do know the value of x3, so just write it down as k as the previous value. And then just the same thing, x3 k plus 1 equals to v3 minus a31 x1 minus a32 x2 over a33 here. x1 you get the latest value already, x2 also the things you get the latest value already. So when we use the calculator, just the things that we did not, a1 as a, x2 as b, x3 as c at here, and then just the same thing at here, b, c, a, c, and then a, b as refers to here. So you just insert it into your calculator in this form, and then for this one you just insert the semicolons at here, and then once you insert the last one you just press the calculate button. And then another thing that wait me a while, so as refers to here, maybe just now I didn't mention it. Yeah, I didn't mention it. So for the Gauss either iterations, we use the initial guess as 0, 0. That means that the top one value at here, we just assume it as 0, 0s to proceed the calculations, and then the stopping criteria just now I discussed with you already. So these two as the important things as refers to here. Okay, so that means that you just insert into your calculator a equals to, so the value, okay, up to the value at here, and then minus the value at here. So just change the variable at here. I will discuss it with you. So what is the functions at here? Just the things that we use the assign symbol at here. That means that once you get the latest value for the x1, it will be stored in your calculator. So once you want to proceed to the next calculation, so you can use the latest value of a in your calculator to proceed the calculation. If you have no latest value of c, just use the previous calculator value in your calculator. So just the thing at here, assign that means once you get the value, you just use the assign symbol at here. Just once you get the value, the calculator will help you to store the value in your calculator since you assign it already. So just the things at here, actually this one, the functions at here is that how to separate the functions. So the equal signs at here, just the things that how you assign the value into your calculator. So for the equal signs at here, just as you press alpha equal. Alpha equal. Okay, so maybe just as a brief introductions with you. So the first thing at here, I want to share with you what is the diagonally dominant first. Okay, so actually all these things just same as the textbook. So if you want to take a photo, maybe you can take a photo for this part. Yeah, wow. Okay, we just refers, actually just refers to these two pages only, all the discussion just now. 1, 2, 3, okay, that. So move it to the next one. Okay, so now I share with you what is the conditions for the diagonally dominant. So diagonally dominant, that means that the diagonal elements that is greater than the summation for the row here. So that means that in simple words, that means that the diagonal elements is the maximum number for the row. for each row. Okay, so in 3 dimensions, that means that A22, A33 as refers to here. Remember the absolute size. So the absolute size at here that is greater than the absolute size of others two as the summations of others two values. So same go to here. The absolute value of the diagonal elements that is greater than the summations of absolute value of the others two at here. Then goes to here that is greater than the summations of the absolute value for the others two at here. And then same go to the 4 dimension one. So for this one that is greater than the summations of others element at here, and then this one. Okay, summation, just remember that as the summation. So there is 5 diagonal element as the maximum number for each row, seen in case that this one as 10, so this one as 2, this one as 7, 7 plus 2 that is 9, 10 still greater than 9 at here. Just the things at here. So how this is the way how I remember E, and then in general form there is AII greater than the summation from AIJ. That means that which is from the same row. So for me, I just remember that the diagonal elements, okay, the diagonal elements that is greater than the others two elements, just the thing. Okay, we proceed to the first example. So remember that for the outsider method, so the first thing is that you, before you get the calculator formula, make sure that your matrix which is in diagonally dominant. If not, you just write it down, matrix A which is not diagonally dominant. If you are able to rearrange it, so you just try to rearrange it and then just write it down, matrix A is diagonally dominant, and then you proceed to get the calculator formula in order to use the calculator to get the answer for it. So actually outside the iterations method, just the simple thing you have to get the calculator formula. Once you get the calculator formula, just the easiest thing, you use your calculator. The calculator will help you to get all the answer for this part. So show you A is diagonally the one at here. Okay, so it refers to here against the thing, so it just refers to the diagonal elements right here. So as you notice that here, absolute value of 9 that is greater than 9, 6 plus 2, yes. Since 9 that is greater than x, so yes. Second one, 5 that is greater than 2 plus negative 2, 5 that is greater than 4, yes. And then the last one, 7. So 7 that is greater than negative 3 plus 1. So 7 that is greater than 4, yes. So since all these 3 is fulfill the condition, so just write it down. Matrix A is diagonally dominant. So in case that this one is not diagonally dominant, try to rearrange it. If you are unable to rearrange it, you just write it down. Matrix A is not diagonally dominant. If you are able to rearrange it, so once you rearrange it and then just write down the conclusion, matrix A is diagonally dominant, just the thing. So you are able to fix out the thing, try it. If you are not able to fix out the thing, just write down the conclusion set here. So for me, since in this question it asks you to show, so you have to show me based on each row the conditions at here, and then just write down the conclusion for me. Okay. So actually you don't want to show me this part, so doesn't matter, you may just show me this part, and then just write down the conclusion. Normally for these calculations, 3 to 4 or 5 marks. Yeah. Okay. So for the next one, matrix A is diagonally dominant. So against the things, so just the things that I want to share with you, the difference. Where's the thing here? Equation 9. This one is equation 8. as you first to here, just the thing, try to rearrange it. So what is the thing here? 11. Okay, so as you first to here, you notice that 9 that is greater than 5 plus 1. 9 that is greater than 6. Yes. And then this one, 5, negative 1. So 5 that is greater than 2 plus 3. So 5 that is equals to 5. So there is no. And then for the last one, 7 that is greater than negative 3 plus 6. No, since 7 that is less than 9. Okay, so if, once you are unable to prove it that is diagonally dominant, you just try to rearrange it. So as you first to here, this one is the maximum number for the row. For sure, this one is the first row. As you first to here, second one, if let's say that you met this one is the third row, so A33 is the maximum number, 3 that is less than the summations of 2 and 3 also. So you are unable to make this one as the third row. So for this one, if 6 that is less than 10 also, unable to make it as the second equation also. So you are unable to show it is diagonally dominant. We just write it down, matrix A is not diagonally dominant. So just remember that try to rearrange the diagonal elements as the maximum number for each row here. So as refers to here, you are unable to proceed it. So it doesn't matter, just write it down that the matrix which is not in diagonally dominant here. Okay, as refers to the conditions, there is no equal sign here. So that means that 5 equals to 5 is not acceptable. So since there is no equal sign here, for sure there is 6 greater than 5, 5 which is equals to 5 which is not greater than 5. Okay, so the next example here again is the thing. So as you notice that here 0 for sure this won't be the maximum number for the row. So we try to rearrange it. So for the A11 we try to find out the value which is as the maximum number as refers to the row. So this one it won't be, since 9 is the maximum number at here. So this one it can be as the fourth row at here. So 3 that is greater than 1 plus 1. So this one can be as the first row as refers to here. 5 that is greater than 4. This one can be the second one. And then this one, 7 that is greater than 5. So this one is the third one. So as refers to here, you may just rewrite it as the first one 3 1 1 0, second one negative 1 negative 5 2 1, the third one 0 negative 2 negative 7 negative 3, the fourth one at here 4 0 1 negative 9. So just the things that you have to remember, that try to find out the maximum number for the diagonal elements that is as the maximum number for the row. So once you rearrange it in this form, as you notice that here 3 that is greater than 2, 5 that is greater than 4, 7 that is greater than 5, 9 that is greater than 5. Okay, so this one which is yeah. Yes, the thing is diagonally dominant. So as you first to here, this one 0 that is not greater than the summation of others value, 0 that is not greater than the others value. And then also the things that here, this one that is not greater and this one that is not greater. So once you write it in this form, so just write it down that greater than 1 plus 1, yes. And then negative 5 greater than negative 1 plus 2 plus 1, yes. And then the third one, the one that is greater than negative 2 plus negative 3, yes. And then the last one, negative 9 that is greater than 4 plus 1, yes. Okay, so you want to show me in this form, or you want to simplify directly as 3 greater than 2, yes. this one both is acceptable. For me, if you write out this one, you don't need to show me this thing already. So in case that you are confident with your calculation, you just write it straightly in this form: 3 greater than 2, 5 that is greater than 4, and then 7 that is greater than 5, 9 that is greater than 5. You just write it down all the value at here as yes at here. So you just write it down. The matrix A is diagonally dominant. So important thing is that before you get the calculator formula, that's one which is in terms of ABC, you have to make sure the matrix which is diagonally dominant before you proceed the calculation. Yeah.
Kita memang kena susun dulu daripada yang dia asal tu.
Ya,
So kena susun balik.
kena kalau tak fulfill condition, kena susun balik. If not fulfill the condition in this case, right? So as you first to here, you notice that 0 that is less than the summations of 2 plus 7 plus 3, 0 that is less than 10, is it right? So this one which is not diagonally dominant, so you have to rearrange it to make it as diagonally dominant in order to proceed the calculation. Since for the condition for the downside the iteration, the condition is that the matrix A must in diagonally dominant form to proceed the calculation.
Boleh ulang balik cara Dr. decide row mana yang first, row mana yang second, third.
Yeah. For this example only, previous example you are able to understand, is it? Sebelum ni faham tak? Faham kan?
Faham. Cuma yang ni tak tahu nak cara tentukan row mana satu.
Okay. Ya. Ini sudah lukis sampai apa dah. So as refers to this example, based on the definition for the diagonal elements, that means that the diagonal elements have to as the maximum number for each row. So as refers to here, for sure you know that 0 that is less than the summations of 2 plus 7 plus 3, 0 that is less than 10 here. So how I recognize the thing at here is that I just try to make sure that the diagonal elements, which is as the maximum number, as refers to the row at here. So based on the general one, that means that I try to find out the A11 that is as the maximum number as compared to the others value on the same row right here. So as refers to here, for sure this one is not acceptable, since 0 for sure this one as the minimum number as refers to here. So as refers to here, as you notice that here, this row 3 that is greater than summations of 1 plus 1, 3 that is greater than 1 plus 1. So 3 that is greater than 4, is it? So this one, it can be acceptable for the first row here. Since for this one, you have to make sure that the first element that is greater than the summations of the others one. So just have a try at here. Okay, 3 lebih besar daripada 2 at here. So 3 that is greater than 4, that is why this one, it can be as the first row. Faham tak ni?
Okay.
Okay, so we move it to the second one. So for the second one, A22 have as the maximum number as compared to the others value. That means that A22 have to greater than the summation of others, these two values. So just try to find it out with this one. Okay, it's not acceptable since 0 for sure as the minimum number, and then 2 is also as the minimum number since 7 which is greater than E. Okay, we have a try here. As refers to here, negative 5 that is greater than negative 1 plus 2 plus 1. So 5 that is greater than 4. So this one is acceptable. So this one you can make it as the second row since 5 that is greater than 1 plus 2 plus 1 at here. 5 that is greater than 4. Betul kan?
Betul.
Okay, so we move it to the next one. So A33 you have to find out the maximum number as refers to here. For sure 1 that is as the minimum number since the beside one is 9 and 4. For sure the summation at here there is what is the thing? For 13 at here. So there is larger as compared to the diagonal element. So maybe you can have a try here as the third one. Since as refers to here, negative 3 that is negative 7 that is greater than negative 2 plus negative 3. So from here you know that 7 that is greater than 5. So it's fulfill the condition also. So this one can be the third one. And then the last one is you notice that here, so negative 9 at here. So negative 9 that is greater than 4 plus 1. So 9 that is greater than 5. So it refers to here, this one can be the fourth equations at here. And then if let's say that you are unable to rearrange it, the condition is not fulfilled, you just write it down that the matrix A is not diagonally dominant. Since we are able to rearrange it, so in the end you will get E which is in this form. So first equation, zeros, negative 1, negative 5, 2, 1, 0, negative 2, negative 7, negative 3, and then the last one at here is 4, 0, 1, negative 9. Okay, if you want to have a check here, may have a check here, 3 that is greater than 2, 1 plus 1 is 2. 5 that is greater than 1 plus 2 plus 1 since we consider the absolute sign. So 5 that is greater than 4, yes. And then this one, 7 that is greater than 5, yes. And then the last one, 9 that is greater than 5, yes. So just write down the conclusions that matrix A is for diagonally dominant. Faham tak?
Right, faham. Masih ada.
Okay. So the important here is that please make sure that before you get the calculator formula, the equations you obtain in your calculator formula that is fulfills the condition for the diagonally dominance. Okay, so we proceed to the next one. Okay, so rearrange if the matrix is not diagonally dominant. So try again, just the same thing, try to rearrange it. So as refers to here, normally right for this type of questions, I prefer to write it with the augmented matrix form. That means that I write it down with the right hand side. So in this case, once I rearrange the equations, I know that the right hand side is changed so together here. So just the thing at here, for A11, try to find out the maximum number at here. So it refers to here, maximum number at here at 6 that is greater than 1. Yeah, this one can be the first row. And then for A22, as you notice at here, 7 is the maximum number. So 7 that is greater than 5. Okay, so the third one, 9 that is greater than 1. So once you rearrange, you may just write it down as 6, 0, 1, 5. And then second one, 1, 7, 4, 2. And then the third one, 1, 0, 9, 3 at here. So 6 that is greater than 1, 7 that is greater than 5, 9 that is greater than 1. So this one, just the thing, you may just write it as matrix A is diagonally dominant. And then against the thing, you have to prove it. So 6 that is greater than 1 plus 0. And then 7 that is greater than 1 plus 4. 9 that is greater than 1 plus 0. So from this one, 6 greater than 2, yes. 7 greater than 5, yes. 4 greater than 1, yes. Just a simple thing. Okay, so in case that once you rearrange it, maybe it's one of the equation is not fulfill the condition, you just write it down. Matrix A is not diagonally dominant. Yeah, nice Siri. Okay, so now we proceed to the calculation for the Gauss-Seidel iteration. So this one, again, the thing I share with you how to do the calculation step by step here. Okay, so again, the thing for me, I prefer to write it in augmented matrix. So up to you. If you don't want to rearrange it, it doesn't matter. If you want to rearrange it, please make sure that you write it in augmented matrix. Please consider the right hand side here. Okay, since as refers to here, all the variable which is in order. So if you want to have a try, refers to here is acceptable also. So for the first one, you have to make sure that the A11 is the maximum number for the row here. So maybe you can rearrange it as this one. Since 5 that is greater than 5x1 minus x2 plus 3x3 equals to 6. This one is the first equation. Since 5 that is greater than negative 1 plus 3. 5 that is greater than 4, yes. Okay, we move it to the second one. So A22 is the maximum number, so this one is acceptable. Since 7 that is greater than 4 plus 1, so yes. And then the last one, just add here 10 that is greater than 2 plus 3 that is 10 greater than 5, yes. Okay, so the thing said here is that rearrange, oh sorry. Oh no. Okay, once you, in case that this one in diagonally forms already, so just write down the conclusions. Matrix A is diagonally dominant. If not, rearrange it. If you can't rearrange it, you just write it down that the matrix A is not diagonally dominant. Okay, since this one you are able to rearrange it, so just write it down. Matrix A is not diagonally dominant. So remember that we proceed this one in order to get the calculator formula for the Gauss-Seidel iteration. So just the same thing. Okay. So x1, x2, x3. So from the first equation, just keep the other thing to the right hand side. So negative become positive, positive become negative over the coefficient. And then x2, so equals to 2 minus 4x1 minus x3 over 7. And then the third one equals to 9 minus 2x1 minus 3x2 over 10. Okay, so just insert into your calculator. So how insert it? So equal sign, just the things that you press alpha and then press the button calculate it. Yeah, you will get the equal sign. So A, B, C, so just the thing B, C, A, C, A, B, insert into your calculator. And then here, insert the semicolon. And then the last equation, place the calculate. So just insert this into your calculator. So for me, normally I just write it down, the subscript beside it. I didn't rewrite it. So maybe someone is confused. So actually this part, which is same as you insert into your calculator as alpha A, alpha equal 6 plus B minus 3C over 5. This one is not alpha equal, this one is alpha calculate. Okay, try to get the equal signs on your screen. And then the semicolons, and then just insert C equals to 9 minus 2A minus 3B over 10. Again, the same thing. If you are able to proceed it, you just write it down, the value beside it, and then just insert this into your calculator. You don't need to write it down, the calculator for me. Actually, you just write it down. When you rearrange equations, if you are confused, maybe you can denote E as A, B, C beside it, and then you may get the calculator formula. So just insert this calculator formula into your calculator. Try to insert it now. And then, so for the table, K, X1, K, X2, K, and then X3, K, H refers to here. So 0. So for the first one, H refers to the condition for the ground side the method. You know that there is all the value as zeros here. So once you insert this one and then you press calculate, the calculator will ask you that the B value, we just insert it as 0 and then press the equal sign again. The calculator will ask you that the C value. Then this one, which is based on this one to ask you, so just insert as the zeros and then you just press the equal sign. You will get it, the latest value there is 6 over 5, negative 2 over 5, and 39 over 50. Once you get this value, and then you press the equal signs again, on your screen, it shows you that the value of B at this one. Why? Since as refers to here, you assign the value to the calculator already. So once it obtains the latest value, it will help you to store in your calculator. So now in your calculator, the calculator store the value that B, the latest value of B as negative 2 over 5, and then you press the equal signs again. So your calculator will show you that the latest value of C as 39 over 50. So no need to do other thing, you just press the equal sign. Press the equal sign, and then the calculator will show you that A equals to the functions as refers to here. So the value show on your screen, there is 163 over 250. And then press the equal signs again, E as negative 347 over 1710. This one is 0.8291. Okay, so you don't need to insert the value. The calculator will help you to store the value already. So in case that you want to write it down in decimal places, it's acceptable. So just write it in 4 decimal places, and remember that please don't reinsert the value into your calculator. You have to do, the only thing is that you just press the equal sign to get all the value at here. Okay, so once you get it and then you press the equal signs again, you will get it. The screen will show you that B equals to this value, C equals to this value, then you just proceed it. Okay, so as refers to the stopping criteria here, it just refers the difference in between the latest value and the previous value here. So as refers to here, the stopping criteria is not achieved yet. So why I know it, since 0, 1, 2, 3. Okay, yeah, wow. Okay, just nothing you have to do, you just press the equal sign. And then as refers to here, you notice that the difference, which is equals to 0.0000 2 actually is negative, so the square root is less than the epsilon number, and then the difference at here is 0.001, that is less than the epsilon number also. 0, that is less than the epsilon number also. So, sorry, I made a mistake here, is it? Yeah. So for this one, actually the difference right here there is 0.0037, that is greater than 0.0005, so you have to proceed it. So you just proceed the calculation, just press the equal signs, you will get yes 0.96594, negative 0.2098, 0.8311. So from here, the difference at here, that is negative 0.0002. That is less than the epsilon number. This one is 0.0001, less than the epsilon number. This one is 0 is less than the epsilon number. So remember that based on the stopping criteria for the Gauss-Seidel iterations method, so as the maximum number is refers to here. So from here, you know that this one is the maximum number, since this one is greater than this one and also greater than 0 here. So that means that as refers to here, the maximum number here, which is less than the epsilon number, that means that the stopping criteria is achieved at here. So just the same thing at here, against the thing, show me the stopping criteria and the approximate solution. So the approximate solution as the latest value you obtain at here. So for this part, if you can't remember, it doesn't matter. X5 minus X4 equals to maximum of 0.002, 0.001, and 0 set here. So as refers to here, that is equals to 0.002, that is less than the epsilon number equals to 0.005. And then the solution. So if you want to write it down in row, remember the transpose sign since the original one, which is in vector form. Okay, so remember that just the thing, you have to show me that the stopping criteria, sorry, I write it here, 2 and then 5. So as you first show here, the stopping criteria, this one you have to prove, and then write it down. The approximate solution is enough already. So this one just as the one of the example for the Gauss-Seidel iterations. Now we move it to the last one, last example for this chapter. So actually the things that make sure that which is in diagonally dominant, proceed the calculation, get the calculator formula, and then all let the calculator calculate for you, and then you only have to know where you have to stop only. So just as you notice at here, the difference of the value, there is the maximum of the difference of the value at here, there is less than the stop the epsilon number. That means that you can stop already. And then okay, so all this I share with you already. Dang. Okay, so the last one. Actually just a simple thing. So I think I write it down. So how to solve it. And then just for the table, I just write it down for you. You may have a try on your own. Then these are the things that you have to know how to use a calculator only. No manually calculations here. So for this one, so just again the same thing. So for this question, it asks you to solve it using the Gauss-Seidel iteration. So as refers to here, the first thing against the thing, you just check whether the condition is fulfilled here or not. So 4 that is greater than negative 1 plus 1. Okay, 4 that is greater than 2, yes. And then 7 that is greater than 3 plus negative 2. So 7 that is greater than 5, yes. And the last one, 5 that is greater than 1 plus 3. So 5 that is greater than 4, yes. So this one, against the things, matrix A is diagonally dominant. Actually, this part you no need to prove it since the question didn't ask you to show it. So you may just write it down as matrix A is diagonally dominant, and then you just proceed the calculation. In case that the question asks you to prove it, so you have to prove it this part. If not, you just check it whether you have to rearrange or not. If no need, you just write it down. Matrix A is diagonally dominant. Is enough already. And then okay, here I write it down since I want to show with you. Actually, during exam, the question didn't ask you to show it or the thing. You just check it and then you write it down. So the conclusion is enough already. Then you can proceed to the calculation straightly. You have to check it. Okay, once you check it, you just write it down. Matrix A is diagonally dominant. And then from here, and then another thing is that please make sure that in case that you exchange the row here, remember the right hand side. Since I noticed that the common mistake for the Gauss-Seidel iterations, maybe you exchange for the matrix at here. Once you exchange for the left hand side, for sure the right hand side which is with the left hand side. So you have to remember that if let's say that this one is as the second row, so remember the second row with the right hand side as 3 is not 2. Just the thing you have to exchange also. Okay, so as refers to here against the thing x1, x2, x3. So as refers to here, there is 4x1 minus x2 plus x3 equals to 3. 3x1 plus 7x2 minus 2x3 x2, and then x1 plus 3x2 plus 5x3 equals to 1. And then just against the same thing, write down the calculator formula. So x1 k plus 1 equals to 3 plus x2 minus x3 over 4. So this one is the previous value, so just write down as k. The second one equals to 2 minus 3x1 plus 2x3 over 7. So this one is k plus 1, this one is k. And then the last one, x3 k plus 1, which is equals to 1 minus x1 minus 3x2 over 5. So this one is k plus 1, this one is k plus 1. I mentioned many times already. This one. Okay, so just same thing, insert into your calculator, A, B, C, this one, just insert it as alpha, calculate. And then this one as B, this one as C, this one as A, this one as C, this one as A, this one as B. When you insert it, remember the semicolons, and then the last one, you just press the calculate button. And remember that for the table, for the initial gas, that is 0. Okay, and then for this part, maybe you can have a try on your own. So just remember that this one is 0, this one is 0, this one is 0, this one is 0. Once you insert B as 0, C as 0, press the equal sign, you will get E, the latest value. And then once you get this value, you just press the equal sign on your screen will show you that B equals to this value, C equals to this value. Since the calculator help you to assign the value already, you just press the equal signs and then write down the value. So for this part, maybe I am lazy to write it already. So I just share with you the answer screen as refers to here. So just a thing, maybe you can take a photo, have a try on your own. So just remember that you have to know where you have to stop. So just what is the thing? Okay, so I should refers to this one as the answer for this part. Okay, maybe you can take a photo. Just the things that you check the difference in between the value at here. So you have to check it whether the value in between here, what is the thing? Okay, so as you notice at here, just these two value, the difference at here, there is 0.007, so that is greater than the excellent number, so we just proceed the calculation. So as refers to this row, the difference for the S1 is 0.002, the difference for the second one is 0. And then as refers to here, the maximum at here is 0.002. So you know that you can stop it at here and then just write down the last value from the table that you just write it as the approximate solution, and also the things that show me the stopping criteria and also the approximate value as refers to here. And then for the next week, so we have no class, so I will give you the, sorry, this one. Tab calendar. Okay, so 23 and 25 we have no class. The video recordings will be provided, and then for the 30th of April I'm not sure. Okay, if I am not around, I will share with you, and then for sure the video recordings will be provided. So I will inform with you later. But for these 2 days we have no class, so all can celebrate the festival. Selamat Hari Raya. That's all for today. Bye.
Thank you.